away from you, that
Bro,
distance
is
changes.
the elevation of this changing as the distance changes? Because that's what's supposed to change.
The elevation from the circle down below?
No, from right here, from anywhere. Because this is okay. This is what was
You talking about
mapped
the
out.
elevation angle or distance? What are you talking about?
Okay, you see the sun going left
Sun and
to
moon,
right
I see it
here.
there.
Okay,
Yes.
these are supposed to physically change in elevation and arc down, like this. This is what's
Okay.
supposed to happen on a globe. When you plot this
Because
out
they
for
have to
when
stay
you
the
plot
same
this out for
distance.
when you plot this out for every observer, you're going to get a
Okay.
physical. You would get a physical elevation change over the distance. That's what would create ground curvature. That's the graphs that he was showing where it didn't do that and all that. This is a 2-scale simulator showing all the data points plotted out and what it would look like if it's following the curvature of Earth versus what was just plotted out with no elevation change. The distance is changing as this moves, but the elevation remains the same. Each observers absolutely cannot derive the same elevation on a globe. It would have to follow this. The whole model is based on this.
I mean, maybe I'm the one that's not getting it. I don't know if people in the chat get it, but let me look at the super chats real quick, and we can come back to this because I am not grasping what we're looking at here. Still, I don't know why the line's coming from the middle. I do understand that you're saying from a globe, this is what you would expect to see, but that line is staying the same distance from the person at the middle, right?
No, you see how
Hold on,
it's
hold on.
physically changing in elevation, though. You see how
But
it's
it's staying the
arcing.
same distance from the person in the middle, correct?
Yeah.
Okay, so I'm just saying that that's staying the same distance from the person in the middle, and it's on a curved path, and it's going down away from that person.
And
Now you're putting them up on.
and it's showing the physical elevation change. This is what would happen if globe, if there was curvature for this to change on. But this is what was measured. This is what was plotted out and measured.
But we know that the sun's going to end up on the other side of the Earth 12 hours later. Well, in that model that you just drew, it's just going to keep going out forever, right?
Bro.
Well, just saying that
that's your.
It seems like to me what you're doing is you're conflating
this.
both models. You're saying you're putting one model and then saying, oh, this would work on a globe, and that is what we see. And then you say, oh, but it's not what we measure. We measure this angle not changing, right? In which case, you're saying on a flat Earth that the sun and moon are just moving like that away from you.
Yes,
right, like this line that you drew up here.
Yes, the objects that we see, how they arc and get lower in the horizon.
Okay, so wait, the distance then to the ground is changing.
That's just how we perceive them.
Okay, but the distance to the ground is changing, and we can figure out what the amount that it would change in angular size. If you're telling me we now know the distance to the sun and moon on a flat Earth, then I can calculate what the change in their angular size is.
You're conflating models. You're conflating Newtonian concepts.
Let's just go to just flat Earth. Let's go back to when I'm a flat earther. I'm a flat earther now. I believe in the flat Earth. Okay,
great.
You're now telling me that we can calculate the sun and the moon distance from the Earth. That's what you're saying. From the flat Earth.
I'm telling you, that's what the trig comes out to based on the occlusions. It's rise over run. Yes.
So we are accepting the trig, but if we look at the angular size change that is expected, we're not going to see it.
If you're assuming the sun is a physical body that you're seeing, and it's not.
Well, that's what you're assuming. You're assuming that.
How so?
Because you just told me that the distance doesn't change and the altitude doesn't change. So how are we getting altitude and distances to things that aren't physical items?
Bro, it's a calculated value based off of occlusions.
Like, right. And so if you calculate the value and it comes out.
Saying the occlusion doesn't happen.
So really, this is what we have to do. We have to believe that the sun and moon are magical. That's what we have to believe.
No,
well,
not really.
They're not. Are they physical or are they magic? Or are they apparent? Listen, or are they pretend?
They're apparent in both models. And the elevation change is apparent too. That's what I'm trying to tell you.
Okay. Because
whatever source of light these are, whatever source of light that is, we don't see the true thing. We only see what is in our hemisphere of vision. That's what this whole thing is plotted out against. This is what this is how the whole thing works. And when they say, okay, we have the true position, which is just the zenith measurement of where it was, and then they add 15 degrees per hour to it. They're like, okay, it's following ball curve. As it's getting lower in the horizon, that means it's physically getting lower. They even attribute negative coordinates to it and say now it's below the ball. This can't be below a ball if it's also in reality physically still above us.
Okay, then it would never set.
I mean, if you impose conditions on it where light propagates infinitely.
Well, I mean, that's okay. Well, so you're saying, yeah, you want to go with light attenuation and it's not infinite light. Okay, I'll give you that. I even think that might be the case anyway. So, but I don't understand how I'm supposed to just give up on the ideas of things changing angular size if we know their distance. right? Like I never could say that as a flat earther. I couldn't say I knew the distance of the sun because it didn't work out from 3 observers.
Right.
It only worked out from 1 observer or
Right,
2. I mean,
dude. And that's exactly how the whole model was based, bro. It's a two-party celestial navigation system. Like that's what the part of there was like a royal decree in
yeah.
1777 where they like were giving a financial reward for people that could make the coordinate system work in the way that you just described it for two people. The
Okay.
whole idea of like drawing triangles to the sun for 93 million miles and all this stuff, all that is supplemental. If you want to actually like use the globe so called and like do celestial navigation, all of it changes the all the distances are assumed to be the same. They just make an equidistant web, and
Right.
what we're showing here is that there's no elevation change in the way that they say that there should be.
So let's say that this was happening and the stars were out, right? So the stars are moving with it. So you're saying that everything then moves parallel to the ground. The stars don't move either because they follow the same paths.
No, they follow the same path, but it's apparent. The actual elevation isn't changing lower. That's why they get occluded by mountains at elevations that don't change.
Right. And so do the sun and moon, right?
Apparently, yeah.
They get occluded by mountains. I mean, that's what the sunset would be.
Oh, yeah.
Correct.
Sorry, I thought you were talking about the eclipse data. Yeah. Yes.
Okay. So I'm just trying to say, so then you're saying that all the stars never actually go lower. They just are staying the same height above the person on a flat earth at all times. As they move away, the altitude stays the same.
Correct. The actual source of the light is physically staying the same altitude, even though it's being plotted on a coordinate system that says that it should be changing in elevation physically.
So then that means that the light of stars is much greater than the sun because they're also staying the same height away from me, and that I can see the starlight way after the sun is gone. So that means that the sun is not as powerful as the stars in the flat earth model.
Bro.
Okay, listen, if you're saying, hold on a second, just imagine that we're looking at the sky and the sun and moon are moving in the sky. The stars move the same speed about. I know it's a degree off or something, right? But they all move the same general speed. Correct?
Yeah.
Okay. So you're saying that the sun and moon don't change their that's when we came in. The sun and moon don't change their altitude away from the person on the flat earth. So then neither do the stars.
And neither do the stars.
Okay. But if we watch the sun goes away and it sets.
The apparent sun sets, absolutely.
Okay. And then if I'm still looking in the sky, I would still see stars past it. Right? The sun sets, I can see those stars.
Yeah.
Okay. Just making sure that that's what you're saying, is that those stars must have a more powerful light than the sun, because the sun goes away, goes out. It diminishes, but the starlight we can see much further than that. Are the stars further than the sun? Let me put that. Maybe that's the problem.
No, bro, I have no idea how far they actually are in elevation, but what I'm telling you is that the source that we see, what we're basing this off of, comes out, what the globe is, saying is true. We're representing it over a flat earth, and we're showing that the apparent angle changes are just apparent. They're not physically changing. That's a huge problem, because irrespective of the distance of the stars or the sun, they should change in elevation physically as per what the model dictates as a physical.
And is that the right height? The way is that scaled correctly?
Yes, this is to scale.
Okay, so go to the flat earth part at the top, and then put like a where an airplane would be above that person.
Oh, I can't edit this.
No, not edit it. I mean, just put your mouse there so I can see.
Okay, gotcha.
So I don't know what the distance is. What is that distance between the ground flat earther and the sun and moon up there?
3 times 10 to the 6.
What? I don't know that math.
I don't know, like 3 million meters, let's just say.
I don't know meters either. Okay.
So let's just say 10,000 miles, and then so now I got the guy at 10,000 miles.
Okay, the plane's that close to the sun?
Bro, what?
I'm asking you to put your fucking mouse cursor where a plane would be above the person on the flat earth. It's not difficult what I'm saying. Put your mouse where the plane would be.
Just anywhere would be the plane.
No, where a plane flies about 30,000 feet. But I don't know your scale, so I can't tell you where to put it.
Oh, I got you. My bad. You said to scale. My bad. I thought it was just like anywhere we could just.
No, I want you to put it where the plane would be.
I got you.
Because so go to 30,000 feet, whatever.
30,000 feet. 2 meters. 9,000. Okay. Where's the... Oh, my bad. Okay. So about 9,000 here. All right, here we go.
Okay, now zoom out so we can see kind of in reference to where that thing is. So that's 30,000 feet where your mouse is?
Yeah, thereabouts. Yep.
Okay, and then you're saying that so when we see out the window of a plane and the sun and moon are lower than the airplane, how does that work in this model?
That's just apparent, bro.
Okay, so I'm asking you how it works in this model. You're saying that perspective moves things lower than our eye position?
Yes. Sometimes people will see the sun in the clouds. It's just an optical illusion.
Oh, well, the sun is in the clouds because it's above your head.
No, I'm
Nobody
sorry.
sees it.
No, like, have you ever seen the video where they're like on the plane and they like show like almost what looks like the orb of the sun, like that's in a cloud?
Yeah, okay, that's not what I'm talking about. I'm talking about you can actually see the
like, look,
sun.
it's close. That's all just optical illusion stuff. And then,
But the sun and moon, we see them go below the plane, the
it
airplane,
looks,
below
it
the plane.
looks, it
You
looks
can
like
actually
it
see.
looks like it is apparently, but it's not.
Okay, but how about with like airplanes? We can see the bottom of airplanes lit up by the sun,
Can
but you
you?
can't see. Absolutely.
Okay.
Do you want me to show you? I mean, well, that tells you that the sun is lower than the airplane. The
Dude,
sun is lighting the
dude,
bottom of the plane.
show me your examples of plane lighting under the thing. But what I'm showing you right now is that there's no physical elevation change. Dude, why
Right.
some
And
lights
so
reflecting
but the
up?
reason I
What?
brought this up is because then
Why?
that would require
Why?
that not to be possible to what I'm saying happens.
Dude,
Right?
light being reflected onto an airplane or whatever is going on with that. Like, you have to show me. I'm not
Okay.
familiar, but show me what you're talking about. And then, but what I'm showing you is that they're never changing in altitude. Now, if you do this same thing on a globe where you're traversing over globe, right, with our
I'm just trying to point out that there's evidence that the sun drops lower than your eye view many times, lower than airplanes. And if you're on a mountain, it drops lower than your eye view. It drops lower if you're on the beach, but that's hard to see because you're right at the water level. But
yeah,
you,
and that's always apparent.
okay, so what I'm saying is if it's
You're never
apparent,
physically higher than the sun.
right, you are. I mean, that's what I'm saying. So if you're not physically higher than the sun, then how would sunlight hit the bottom of an airplane? Would it do that?
You have to show me what you're
Okay, I'm
talking
getting
about
there.
specifically.
Get in there. 1 second. I don't know how far back it is in this. Let me find it if we can. Where is this? Why don't we? Nope. I'll find it here in a second. Maybe somebody's here. Damn it. Oh, there we go. Thank you. Share. And I know that Dave McKeegan did a whole video on it too. I was going to find this video though. Let me put this one in here. Telegram, save messages. I wonder if Dave's around. Save messages. Because I think if we can show then that there's evidence that obviously the sun does go down. All right, let me find it here. Oh, I know what I would look up. Let me look at this. This is it right here. Let me bring up his video of this. So yeah, this is right here. Let me see if this is it. Sorry. Okay. Sorry, my computer's bad.
I can't hear the audio.
Oh. me try to bring it up for you. Go choose the send. Can you just listen to this part on YouTube? Because I don't know how it's not picking up.
Yeah, can you send me the
sorry.
link, and I'll play it real quick.
Wait, the link to my show or the link to this video?
Video.
Yes, I'll put it into Telegram. If I can find you. Oh, there you are. Okay, here you go. That's that video. Yeah, just listen to. I'm actually. What time is this at? He's at. It's only 8:14 video, but just listen from 5. It's almost 6 minutes. You can listen from 6 minutes on, 6 to 8. So it's only 2 minutes you're gonna be listening to.
Okay.
And I'll play it for people here, just so you can hear the explanation here.
You didn't send the link yet.
What? I didn't send what? Sorry.
You didn't send the link yet.
I didn't hit enter. There you go. Sorry.
Hello everybody, hope you're doing well and thanks for joining us for what will be a relatively short video this week, because I'm also working
of the plane. The bottom of the plane is shadowed because the sun is still above the plane. Just like it's still above our plane, it's just moved far enough away to where we can't see it anymore. So Dave McKeegan's simple observation to debunk the flat earth is just ignorant.
Unfortunately for Joe, though, he's actually just perfectly demonstrated my claim. Now, to be clear, I never claim that the sun is always visible on the underside of planes. It depends on multiple factors, like whether there are clouds blocking line of sight of the light from the sun to the plane, how far beyond the horizon the sun is and how high the plane is. If it's too early before sunrise or too long after sunset, then the sun might have already seen to be set for the people on the plane. If the plane is at lower altitudes, like the one in Joe's footage, then the sun will set sooner for them than if the plane were at 30,000 feet. And you only get the reflection when the plane is in line of sight between you and the sun. So if the plane is flying towards or away from you towards the direction of the sun, then this reflection can last a couple of minutes. Whereas if the plane is flying perpendicular to you and the sun, then it's going to cut across that path pretty quickly. But the sun would never reflect off the underside of a plane on flat Earth, as Joe himself points out, because the sun would always be higher than the plane.
The bottom of the plane is shadowed because the sun is still above the plane.
So not seeing a reflection on the underside of one particular plane does not disprove my observation for the globe, but seeing the sun reflecting off the underside of any plane disproves the Earth being flat and the sun being higher than the plane. And eagle-eyed viewers may have noticed that as Joe zooms in his video, the underside of the plane lights up with a reflection of the sun. Someone actually commented about this on his video, but he tried to argue that that's not the case and that the light is reflecting off the top of the plane. Except here is a frame grab from Joe's video as the plane is lit up. And zooming in, that is clearly the underside of the plane. We can clearly make out the shape of the plane. I mean, the tail of the plane is a clear reference marker for where the top of it is, and yet the sunlight is on the opposite side, meaning the sunlight is reflecting off the underside of the plane. It seems quite ironic that Joe claims that
he does another video where he does some actual examples, but I'll show you one that somebody has that actually shows a better light underneath the plane. Because again, what he's saying is that Joe went and filmed one plane and said, look, there's no light underneath it, even though in his own film there was. But like Dave said, not seeing it one time is not evidence of anything. You'd have to, but yet seeing the light shine off the bottom of the plane is evidence that the sun must be lower. Because there's no example. Now you might go to clouds, but the difference between clouds is light shines through clouds and it doesn't shine through planes. So we would never have a case where light should be seen underneath a plane unless the sun is physically lower. But again,
we'd have to get some more information about the flight to determine like angle of the plane. Like this, was it turned a little bit? Others like where was it?
No, regardless, how could it have the sun underneath it?
What was it flying over? Was it flying over the ocean or something? Like there's other factors to consider there. I wouldn't argue that seeing this reflection on the underside of a plane proves anything. It's apparent. Like the
not
sun,
apparent. How could it? You can't show anything that has light hitting the bottom of something that the physical light is above it.
Bro, you showed a video of a guy filming a thing. We don't even know what the plane was flying over, where it was, or what the if it was or we don't know the pitch or the yaw of it. Like there's a lot of other factors to consider to explain how a reflection happened on the bottom of a plane versus no altitude change over 7 million meters, dude.
I don't know about 7 million meters, but that's, again, I don't even know what that is.
It was the length of the shadow going across America.
Right. I guess what I'm confused about that is, again, don't you expect that? Let's say the Earth were a globe, and you had people in California and New York. Would you not expect the sun and moon to be the same height for both people?
No, look at this right here where I'm zoomed in on what the globe.
Where are
would
we
be
looking? Hold on. Sorry. Now you have to tell me where we're looking.
Oh, sorry. I have to reshare. Give me 1 second. I think I have to reshare. StreamYard. Share. Entire screen. Let's see.
I've never seen this video about this.
So look,
Kind of
check this
this
out. You see how on the globe, as you get further out,
Hold on, let me bring
there's-
it up.
it starts to get lower. There's a deviation in altitude.
Oh, nobody can see what you're doing yet. Hold on.
Okay.
Okay, go ahead.
Okay.
We can see it now.
So as we start off on the globe, as we get further away, the curvature starts to become more apparent. You see how I'm scrolling out and this is starting to get thicker?
Yep.
Okay. So if we extended this out for 7 million meters, what we have here is a deviation from a plane elevation. So something has to, if something's following the curvature of Earth, as it's setting, then there's going to be an elevation change for the observers that are viewing it. You can't calculate the same elevation over the 7 million meter distance for everyone unless the object is actually also still parallel to the ground with no deviation. So when you say like you expect that, you expect the wrong outcome.
Okay. And you've seen before, like sunset on where the mountain gets the light blast and things like that?
Yeah, tons of that. There's actually a good video of it right now I can bring up. It's just another instance of, like for example, if you're standing in the shadow, that's the way you'll see it. When you stand on top of the mountain, you see the same shadow going out to the horizon. It's just an optical illusion based on where you're standing. The shadow alone, based on where the observer is at, doesn't tell us anything really unique, except for it's been a minute since I looked into the shadow thing, but there's a whole bunch of stuff on that.
Let me do the super chats because I told people that and I'm lying now, so I don't want to lie. Okay, let me go to the super chats. I'll read you those real quick. Super chats. All right, so we got Dave's Waffle House. Thank you very much. £2 says top man, big respect. JSS Tiger, $5 says Alan, you don't do math. You don't have the right to present yourself as an expert on celestial mechanics.
Top of the clouds.
From Jesse, $5 says Alan lied about the formulas, claimed to have a formula that worked, but would not give it to me. What he had previously given me didn't match reality. Any response to that?
Yeah, the formula that we gave has always been the same formula. They're published right here on the notation guide for the celestial theodolite. There's never been a different formula. Like, ask them for the different formulas. Like, I have no idea what.
So anybody can go to that page and they can get the formula and they can do that themselves.
Yeah, it's all based off of rise over run, and then there's a little bit of central angle theorem that we reference, but it's all straightforward. It's the most basic trig you could do.
Thank you. We've got Kango 4457. Thank you for the New Zealand dollar. Says Alan, everything we see is apparent. It is a refracted pencil in a glass of water has real position. So the sun has a real position. Just say magic. It would be less embarrassing for you. The sun sets because of magic. Okay, we've got from Jesse, $5 says, if Alan won't debate me, just have me on and I'll show that he's deceiving people with the celestial theodolite BS. His results do not match reality. Okay, from Jesse again says, the flat earth model predicts whatever magic is needed to make the flat earth appear to measure like a globe, including sunlight bending 100 degrees. Well, more than that, 180 degrees, really. From Jesse says, Alan lied about my CT measurement at 25 miles being indistinguishable for flat versus globe. He's previously agreed that 25 miles was sufficient distance. Okay. We've got Slitherly.
Yeah, real quick. Let's pause.
Yeah.
Let's pause on that real quick.
Okay.
It's not about the distance. It's a ratio of a triangle. It's a combination of distance and elevation angle. So the mountain that he specifically went to and chose and made a simulator to see if it would work was like the lowest possible angle that you could get. And it's not about just the distance there. It's indistinguishable.
So it's a very small window that it works, or no, or it does work universally.
No, dude, the globe only exists as that ratio for the measurement. Like what he did specifically was went to where it would work out. Everywhere else that you go, where you're not trying to specifically fix the ratio to get it, it's not close to a globe.
Okay, so like if this were real, I just want to say something. If this were real, then there would be a way that people could go and verify this themselves. So there's an easy process to do this.
Bro, no. That's actually, you just reminded me of something. Not only is it repeatable and everyone else can do it, we're actually paying people to do it. Now
Okay.
we already now
I've
we
seen
have
people
the
request that, but I didn't see anybody answer it.
yeah, we have the see I just put out the celestial bounty. So am I still screen sharing?
Yep,
So right here, if you could put this in the chat or put it in your Telegram as well,
it's on the screen. Go ahead.
forward it to people so that they know where to get it.
Okay.
We're offering up to we have a $300 pool, $50 per measurement. All you need to do is have the ability to record stars at night and make sure that
Mhm.
the peak that you're filming is distinguishable. So in the example here that we're looking at, you can see the star and you can see the outline of the peak. That's all you need to do. The quality can be a little less, but
Okay.
as long as it looks like that, you're good to go. All you need to do is write down your latitude and longitude coordinates of where you're recording from, the name of the peak, which you can get from a peak finder website or something similar. You could look it up so we can get the necessary information from that. And you
Okay.
just need to give us the timestamp for when you started the recording of your video so that we could math out what it would be in real time for the star's position and stuff. So we just need most recording devices will start the file name with the timestamp of when you recorded it. So if your device does that, you're already good to go.
Okay.
That's all you need. Just record looking at a mountain and have the mountain in the center, obviously for the peak to make it easier and remove ambiguities. And that's it. And so in the South specifically, because we have a bounty going, so we need some Southern Hemisphere observation. So if you live in the South, any distance, there's no like bad distance. It would be interesting to see what happens over a wide range of them. But what we found is that if you're about 5 miles away from a peak, there's not really any distinguishable distance. So preferably, if you could be 10 miles plus and do increments of 10 miles out, you could even use the same peak in the same night. So you could make $50 per video per star occlusion, so long as you're following the distance intervals.
Okay.
And
Thank
that's
you
it.
for that.
And then in the north, if you live in the north, if you live at sea level, we need some more sea level measurements. We were only able to get 2 of those, and so we need to get some more. So,
Okay. We'll keep going with super chats. We've got where are we at here? Alan, we've read that one. Okay, so we got Slively says, "What's up, Jeran? How do you feel about our $50 vast bet for 2026 now that their tech demonstrator is now in orbit?" What? I don't know. I don't even remember making that bet, but it sounds like me. So I'll have to look into it. You said vast. So I said that vast wouldn't launch. Is that what it was? Or vast wouldn't go to space?
Oh, dude, I was going to ask you about that too. So do you remember that guy you bet for the Artemis project, I think it was, or something?
No, it was for Dear Moon.
Oh yeah. Did that guy ever pay you out or what? What happened with that?
No, now the nice thing was that because MC Toon, he thought he was going to convince the guy to pay me, so MC Toon paid me the money and then said he'd get it from the other guy, and he has not paid MC Toon.
Oh wow.
So yeah,
well, at least shout out to Toon for covering that.
Yeah, shout out to Toon. Shout out to Toon for that. That was nice of him to cover that, because I would have just kept going after that guy and calling him a dirtbag, because he just basically said, "What's he going to do? I'm in a different country." I'm like, oh wow.
So Jeran, real quick in between super chats, let me show you this simulator that Jesse made.
Hold on, let me make sure you're on the screen.
So that he could cherry pick an observation to fit the ratio needed where it's indistinguishable. So what he did here is, if you just move this slider here, right, when they become indistinguishable, this is where he went to go make his measurement. That doesn't, like, that's by definition cherry picking. Like all the measurements that we have are the ones that came from Mike originally. He lives in Colorado. There's mountains to his east and to his right, or there's mountains to his east and to his west. He just picks the ones that he could see. Kat and I got a sea star, did measurements. We did one in the parking lot of a Dollar General that was shut down. That was our closest measurement at 5 miles, and then we did another one that was like 49 miles. So there's a lot, like, building a simulator, looking for a spot where there's no difference, going and measuring it, and then concluding that it doesn't work, even though
I agree with you. That's not right. The way to do it. Okay.
Even though even though the emergence happened with our principles and all that, he's like, it's just a.
You're claiming that if we moved anywhere else, that the globe result would be worse off than the flat result.
It's like that everywhere.
Yeah, so I'm just getting you to verify that.
Yes.
Okay.
That is what the data shows.
Okay. We've got, have you gone full redart? No, I don't know what you're talking about. I'm not going to argue things other than what I know to be the case, which is the shape of the Earth. So besides that, if you're talking about NASA missions and stuff, you're not going to catch me debating that. Human being, thank you very much for joining the club. Jesse says Kevin Samuel thinks Alan is good at math, but Alan can't recognize that the circumference of the equator cannot be 24,901 miles on a flat Earth. 2 pi r. Okay. Does Alan deny Haversine on Earth? Haversine allows for 4 equidistant positions on Earth, but it is impossible to have 4 equidistant points on a plane.
What equipositions are built that function as that? Like, that's not even, like, calculatively, that's true. But what even functions off of that? There's literally like nothing.
But on a globe, could you not have 4 equidistant points?
Yeah, no, for sure. And then also regarding but I'm saying, like, what terrestrial features and what part of engineering is predicated on doing that? There's nothing.
The Haversine, though, isn't it?
No, that's not what the Haversine does. The Haversine calculates distances between a spherical coordinate system. It uses the radius.
Yeah, I know that, but doesn't it use the 4 equidistant positions to come up with that formula?
Not that I'm aware of. All you enter is your latitude and longitude, and it does like the cosine between it. So I'm not sure.
I'm not sure about that either. I thought that that's what it used, but I don't know. All right. We've got Alan. Are lines of solar noon and lines of longitude straight? How can they converge going southward and northward of equator if they are straight? Wait, hold on. Are lines of solar noon, okay, gotcha, and lines of longitude straight? Well, yes. How can they converge going southward and northward of the equator if they are straight? Oh, I see what you're saying. I don't know. You don't have an answer for that. Do you? I mean,
is he talking about how the lines of longitude are flat on a Gleason's versus curved on a globe projection?
No, but he's saying lines of solar noon. So if we drew a line of solar noon from everywhere that's seeing the sun, so say it's the equinox and we draw a line of solar noon, then they converge going southward and northward of the equator, but they're straight. On a flat Earth, they're just straight lines, but on a globe Earth, they would have to come back around and meet, right? South Pole or wherever. We got, what is this person? OMF Glows? I don't know what that is. OMFGOLZ. I think Alan's model is consistent, but he needs to bite the bullet that people at the South Pole could hold hands and be mapped on opposite sides. Well, yeah, I think he gets that's, so what he said is show me the people holding hands. Now, again, I don't know, that wouldn't convince him.
I basically showed a series of people holding hands, showing that there's no curvature. And then, like, your proposition was they could hold hands if they, if they were there or whatever. So, like, that's why I said, well, show me what you're talking about, because I can show you what I'm talking about.
What I mean is that people who went to the South Pole, they start from 3 different locations, right? Like, you can get to these.
No, I got you.
Okay. Just making sure, because there's no such place on that flat map that works. Like here, you can't have, we have a South Pole somewhere on the Earth. And let's just say that it's what we used to call it as a flat earther. It's a ceremonial South Pole, right? So they've got some place that they mark in the ice and they call it the South Pole, somewhere on this map. Now, this person can get there in 5 hours. This person can get there in 6 hours, and this person can get there in 7 hours, but they're the same place. So you now need to find a place on this map that we can draw a location, let's say here, and say, now, can those people get there? Can this person get there in 5 hours? Maybe. Can this person get there in 6? Never. Can this person get there in 7? Never. So you're going to have a problem with, we know that the South Pole exists. I know that it exists because I've seen the South Celestial Pole. So what else would be below it? I mean, you'd have to now invent something that doesn't make any sense. I saw it. We were here. Where were we? Here. And it was about like in this area, the South Celestial Pole. And when we flew to Union Glacier, it'd be out here somewhere. Okay. So this is South Celestial Pole. Below it is the South Pole. Now I knew that by going in that direction, whenever the sun was at its lowest, so say the sun's coming around here, and it's at its lowest at 15 degrees. If I walk towards that, the sun's going to rise up by 1 degree every 69 miles. So the same thing is true no matter where these people are here. They were all at the same, we're all at the same longitude. So we're all at 80 degrees south right here, right? So, or let's say we're here at 53 looking at the South Celestial Pole. That means somebody here at 53, somebody here at 53, somebody here at 53 are all going to be looking up into the sky, and they're going to see the South Celestial Pole, and they're going to know the South Pole's below them. So they could all walk in that direction. Yet on this map, it's all opposite each other. We'd be going this way. And yet we would meet in a very short time at the South Pole. That's how they found the South Pole. So this tells you that this map can't be right because this has people going in opposite directions. Where on the globe Earth, they meet at a point, and that's what happens in reality. And anybody could say, oh, Jeran, you don't know that for sure. Okay, what that would take is that you would have to have a world where somehow they knew that at Union Glacier, it matches perfectly the globe model, meaning that when we flew out here, they knew, well, let's say we're at Union Glacier, they knew that right there, they're like, yes, they would only be 600 miles from the pole, but it's really, much, much more from somebody over here at the same longitude or the same latitude. And somebody over here at the same, no, it's the same for everybody. If everybody is at where we were, 80 degrees, they would all see the sun do the exact same thing, 15 degrees in the low, 35 in the high, if it was the same date. They would all see that. And if we all walk towards the southern part of the sun, it would be in the same direction. Yet on this map, it's the opposite direction. The lowest part of the sun is going to be here for this person, here for this person, here for this person. So they'd all be walking there. This guy would walk here, and this guy would walk here, and yet they would all meet. So, I mean, it just tells you that the Earth cannot be this map. It has to be the globe because that's the only way that reality works. And again, just to show one other thing with this map, what's out, if this is the map of the Earth or this is what we think it looks like, then the sun is required to go to the right like this, around clockwise. Okay, but here in Punta Arenas, when we looked west, the sun went this way, completely the opposite direction that it's supposed to go. It's supposed to go this way, it went that way, and then it rose this way. Like what? How the hell did the sun do this? Well, it does that because it's actually lighting this area on the other side of the Earth, on the other side of the globe. That's there's a model that gives me an answer that goes, oh, that explains everything I've seen. Same thing with the sunset and sunrise going the opposite directions. Everybody in the north, every time we've ever seen, imagine this is the horizon, and we're looking west over water. Actually, be better if I just get rid of this whole picture. You can make a better sense of it. Okay, so let's say that we are, oops, let me get this. Looking out over the water.
Bro, on an
explain this to me.
An AE map preserves directions. It's an azimuth preserving map. So it's not going to be a different direction, bro. You've got a huge fundamental misunderstanding of conflating the globe and the AE map as a model.
Okay, so hold on, tell me this. So I'll go back to, let me just tell me this. You're saying that if this circle, let me go right this, let me grab a circle. If we take, let's just say this is the sun path. Get rid of that. Okay, so this is the sun path. So you're telling me that the sun always goes in this direction, correct? Meaning to the right.
I'm telling you how you perceive it is latitude dependent. So if you're in the north, you're going to see
Stop saying that. I hope you understand how dumb that sounds. Everything is latitude dependent. Everything in the sky. So stop saying something that is true every time.
And what else did I say in addition to that?
I don't know, but stop saying latitude dependent.
Single observer latitude dependent, bro.
No shit. That's how it works in reality.
Good.
Stop saying that, though. It's the dumbest thing I've ever heard anybody say. Latitude dependent. Of course it is. It changes no matter where you go on the Earth. It's going to change the sky. So it's latitude dependent. So stop saying it.
It's going to do that anywhere. That's how we perceive it.
Didn't I just say that?
If you're in the south, you're going to see it Antarctic. If you're in the north, you see it Arc. It's individual to you. We just went over how.
I thought you said that this is the map looking down on it.
Bro,
you have two different worldviews, dude. In one, you want us to believe in the real Earth that we're looking down on, then you want to pretend that there's a pretender.
Can you stop interrupting me, please?
No, because I was talking and you interrupted me. I asked you if the sun is moving in this direction, right? Isn't that true? If we're looking down at the Earth, is it not moving that direction? Or you're saying for some people down there, it moves the other direction?
Who's on top of the Earth looking down? We only
me right now. Me right now. We're looking at it
from a God's eye view. No, all you see is latitude dependent where you're at as the observer. And if you're
everybody who's watching,
equator, you're going to see it go. You're going to see it arc. If you're in the south, you're going to see it Antarctic.
Right. So you're saying that the sun goes in two different directions, and we never see it actually change direction.
I'm seeing
because it has to go.
I'm saying.
Hold on. You're saying if there's a guy here in the south and a guy here in the north, there's two people here. You're saying this person sees the sun go this way, and this person sees the sun go this way. Yet nobody can explain why that would ever be the case, except for if you put it on a globe, then it all makes sense.
Well, you keep saying there's no explanation for it, but if you see it if you see it individual to you and it's just apparent, that's exactly what the Cel-Theo is showing.
No, so what you've done now is you've taken the real observation from the globe. You've taken an observation of one thing going left and one thing going right, and you've said, well, that's what you see. It must be dependent on the person because we have to believe in a flat Earth, even though the globe answers it without any bullshit. It answers it.
So listen, when you say no bullshit, right? You're just talking apparent positions of the bodies. Any model can be constructed of that, as per Copernicus's advice to us. What I'm saying is that when
Okay,
you
right.
have,
Okay, so
when,
we can draw any map that we want and
Here,
make it
I'm
work.
literally in the middle of
Okay,
saying
go ahead.
something. When you're just saying, oh, this body's here, this is where an observer saw it, we add 15 degrees per hour to it, it'll come back. That's what the whole model is based off of. What I'm showing you is that there's no actual physical elevation change over the greatest distance possible that could be measured.
Okay,
So,
that is
so hold on one second. So when you say, oh, this person sees their own sun and that person sees their own sun, that's the only way that I could physically explain why there's no elevation change. If there was an elevation change, I'd be a glober. It would be the single-handedly most conclusive proof you could provide. It would be that physically significant. There isn't any. It doesn't do that, bro.
Okay, yeah, and I'll figure out what you're talking about there. I mean, again, I'm a little bit confused on that one. I'll admit that. But on this one here, where I'm just talking about, this is the kind of evidence that should be end of story. Because again, if we look, well, let me just draw this real quick, and we'll come back to this. But if we take this, I was going to draw it before, and I'm just going to say we're looking. I want people to understand that the flat Earth is trying to change this proof by saying, oh, well, it depends on which way you're looking. No, it doesn't. Because I'm not telling you to look in any direction but except for towards the sunset. So say this is water. I know it's purple, whatever, blue. There we go. And we're looking over and we're about to watch the sunset. So which way are we looking? Everybody should know, oh, you're looking west. Obviously, we're looking at the sunset, so we're looking west. Everybody in the north sees the sun set like this, left to right. That's how every sunset is every day. Doesn't matter the season, doesn't matter anything. It just matters that you're in the north, the sun sets left to right. Now, you may see it set a little bit more like this, or if you're way up high north, you might see it set a little bit more like this, okay? But it sets left to right. Now, when it rises, now which way are we looking? Well, we're looking east if the sun is rising. And every time it rises in the north, it rises left to right. Everybody's in the north. We've never noticed this. We don't pay attention. That's the way the sun always will rise up past the horizon. It comes this way. Okay. Now, if you go to the south, now on a flat Earth, there's no difference in between the north and the south. Why would it change? But if you go south, as soon as you go south, now the sun sets right to left. And every single where in the south, and it just changes, maybe it's this way, towards the equator, it's going to be more like this. And if you are watching it rise, oops, too far. Watching it rises right to left. Okay, so now this becomes a paradox for flat Earth. What you've just said is that two people on the flat Earth, let's say this is the equator here, and you've got one person in the south and one person in the north. Those two people are watching the same sun go in the same direction, yet this person sees it go left to right when it sets, and this person sees it set right to left. So now what you have to believe is that Alan just says that, yeah, this person just happens to see it go to the left because it's latitude dependent. Yeah, we know that. But if we're asking which model
observer dependent as well, where they're located.
Of course it is.
That's the significant factor in this, bro. We're seeing an apparent object always. It's an apparent change in elevation. It actually never changes elevation. So how it works mechanistically, obviously the globe says,
this person would actually see the sun, would see the sunlight on the water here, and this person's going to see the sunlight shining on the water here. Right? If you're looking at the reflection, I drew it above the water. This person's going to see the reflection of the sun here, and this person's going to see it over here. But you're saying that they're the same sun.
Well, everyone's going to see their own individual sun rays anyway. We know that from sunbeams on the ocean and also crepuscular rays. Everyone sees their own individual ones. It's like it's a unique feature that no other light source in the world can reproduce. And you're like, oh, is it No,
every light reproduces that.
It produces unique crepuscular and anti-crepuscular rays and unique sunbeams. It doesn't illuminate the whole entire area that it's illuminating.
It does, but you need to show me an example.
It doesn't do that at all.
But if you need to show me an example of us looking in a certain direction, so let's say we're looking at this as a wall or something, and we have to both see the same light moving in one direction, but we see it go in opposite directions. That's what you're saying happens. So we have to then say, which doesn't happen like when the sun's setting or something, we would see the light come to our feet at the beach, but it would come to each person. We don't see it going in different directions. Everybody sees the sun going the same direction.
Based on where the observer's at, the sunbeam comes to them.
Okay, that's a good point. So let me show you what you're saying now. If we had the equator here, let's just say, and there's somebody in the north and somebody in the south, and this person's looking out at the water watching a sunset, and this person watching a sunset. This person sees the sun going this direction, okay, and this person sees it going this direction. So now you're saying that that's because of it's an apparent position, and everybody sees their own sun. Mm-hmm. So tell me why did it, when we crossed the equator, why would this change?
I have no idea.
Well, I'll tell you why.
I mean,
So
you could
well,
see. So here's the thing. Here's the thing. You could tell me why you think it is, because Earth's a sphere, is what they would say, right?
Not what they say, but that's the only shape that actually predicts this. There's only one shape in the world, Alan, that says, oh, if you're on this shape, guess what? You're going to see the sun go in two different directions because you're standing opposite each other.
And if the shape of the ground was what you think it is, then there would be 4 million meters of deviation over that 7 million meter line.
Okay, you keep talking meters. I don't even know what we're talking about there. I'll go back and watch this again and get the actual measurements in miles so I can see what you're saying. I don't know if you're talking about something close or far away. Don't even have an idea. I'm serious. I don't know what you're talking about. So
it's fine.
I have to.
So
yes.
Listen,
but I see what you're saying about the
disagreement that we're having is like.
And here's what I'll say to you. I'll say to you, if the Earth is a globe, then it must happen like you think it should. So I agree with you. So I'll find out why either it doesn't happen or it does, and you're mistaken. One or the other is true.
God bless. That was a main goal of mine to come on.
Okay, well, here's what people should recognize about me. The difference between me and another glober is that I'm still open to it being flat. Very open. In fact, I prefer it to be flat. I would like it to be flat tomorrow. Be great to get off the globe hill. However, for me, I cannot do that because in every instance, the globe predicts what I see. Okay, so if you're bringing up something that you say here, Jeran, does the globe predict what you see here? No, according to you, it doesn't. But I'm not going to just go along with you. I need to follow up with that. So I'll follow up with it because it is something that needs to happen on a globe. If you're saying it doesn't happen, I want to figure out why.
No, fair enough, because that was a big part of why I wanted to come on too, because I know a lot of the Globe audience is going to watch this. Most of them will hand wave dismiss it, but there will be a few math lads that will look at everything, ask questions, and want to know the data.
That should be the goal. That should be why we have these conversations, because we should be able to get past some things. That's why I asked you those 3 questions at the beginning, because it's no use in me talking to people who want to say I didn't go to Antarctica, who want to say there isn't a 24-hour sun down there. It's just it's not worth my time.
Bro, the only reason I could argue this in good conscience is because the Cel-Theo measurements did not go the globe way. Like, I was prepared to, like, when the FTFE thing happened, or I'm sorry, when the TFE thing happened, and we were all like, oh, we didn't expect that.
Yeah,
I wasn't gonna argue for it anymore until Mike proposed the null hypothesis argumentation, which was pretty good, but it still didn't quite feel as good to argue it. But then the self that we do with other people is that like a few dependent effects are mutually exclusive to the globe. So it's just, I just kind of like reiterate it.
No, I mean, latitude dependent, I guess for me, that just means that it depends on the latitude of what you see. Well, of course, that nobody claims that it's not that. Nobody says, oh, it doesn't matter what latitude you're at, you're going to see the same thing. No, if you're at a different latitude than somebody else, you're going to see something different. It's like saying,
it probably comes off as like redundant, but a lot of the people that we argue with are trying to say that like that alone is mutually exclusive, and it's like, well, if we see it in
a little different color, this is the South Pole, this is the North Pole, and this is the equator. Okay, so what's crazy is that if we look at the arc of the sun, let me grab like this, let me do this ellipse. I mean, oops, not that one, this one. Okay, so this is the path of the sun. Okay, so here, so as you move to the south, it would start like that. South, I saw the sun unbend like this. Oops, damn it, I knew it was going to do that. The sun went down over here. Then when you go further, well, the sun lifts up until, guess what? You see this. Now, above you, the sun just does this. Okay, and then if you're like, oh, I wonder what it looks like in the north. Well, yeah, 6 months later, because the sun moves back over there, you get a model that shows you that the north is the opposite of the south. Here's the model that tells you that, yes, at the equator on the equinox, you're going to see this. Then you're going to, so as soon as you got dropped somewhere with a blindfold on, and you saw the sun setting like, let's say this direction like this, you would be able to know, oh, I'm about mid-latitude, because it's not going to be outbent and it's not going to be straight up and down. This is about a 45-degree angle. You would know that you're at about a 45-degree north latitude. So the Earth is like, tells you the shape of the Earth. The sun tells you the shape of the Earth. You don't need NASA. You don't need Haversine formula. You don't need all these crazy, you don't need stellarium. You don't need to erase refraction. None of that. You can tell the shape of the Earth simply by watching the sun, period. And the sun goes the opposite direction once it's in the south. Well, this is the model that tells you why. The model that says that you're on a globe, and that as soon as you flip, so again, if you drew a globe here, I don't want to do it real quick, but I'll just do it for a second. So if you have a globe here, and you have somebody standing here and somebody standing here, that those two people are going to witness the sun, even though the sun's going the same direction, you're spinning the same direction, whatever one you want to believe, those two people are going to see it moving in opposite directions. So there's a model that explains and describes what we see. And so to refute it, to me, like you said, I would need to find parts of this model that don't match reality. For me, I cannot find that anymore. Now, you might say, well, Jeran, you've measured curve. No, not really. But I don't think I should expect to. I think that's pretty hard to measure curve on an Earth the size of our Earth. So don't expect to measure curve. Now, I have measured it if you're talking about my rocket launches. I'm 188 miles from Vandenberg. I can film the rocket launch. And when I go back and play it back with the live stream, I don't see the rocket on my horizon for 1 minute and 5 seconds. Count right now to 65 seconds in your head and realize how long that is from the point of time a rocket launches until I see it on my horizon. If the Earth were flat, I would see it quickly, not 1 minute and 5 seconds later. But guess what? When you do the math on the minute and 5 seconds, you figure out that the rocket's 34,000 feet. Then you go look into it and you're like, oh, the curvature of the Earth. Oh, guess what? Vandenberg is 34,000 feet below me at the 188 miles. So that,
dude, and if things like sorry to interrupt, but and if things like that were, if things like that were true, then the celestial theodolite measurements would show that curvature. Like the whole, how do we determine curvature and all that? That's what the celestial theodolite makes terrestrial measurements with respect to with respect to the stars, like literally showing that there's no elevation change, like what you showed earlier with the sun at different seasons and times a year being at different elevations and locations. Is all
what did I show? What did I show?
Earlier when you just showed the tilt angle for the sun based off of where you're viewing it from and what season it's in.
Right.
So if all of that is based off of the apparent position, and that's why I'm saying what I'm proposing is unique, because this goes off the true positions and there's no physical elevation change, which is absolutely required if the Earth is truly a globe.
Okay.
Because just
and so
looking
you're
at
saying
the sun,
does the globe not say that is where the sun is? I mean, so in the globe Earth, I can pretend that the sun is real.
Not for the true positions. So if you were arguing that, then the true position would also be following the same arc as the apparent position, but it actually doesn't in reality. That's the significance of the deviation between the two. So we could see one as a conceptual model, and the other one is we could see the deviation from the conceptual model from what actually happens.
But you're saying, so on a globe, where are you saying the sun actually is? Then it's never where it says it is.
Even they agree to that. Yeah, it's always apparent in both models.
Okay, but it's apparent by off by a degree, where yours is off by 180. Big difference.
Bro,
big difference.
Dude,
you're telling me what is the biggest deviation? I'm sorry, what is the biggest deviation of the sun?
Listen, you keep going back to the God's eye view version and saying that it's like a singular source that both people have to be viewing to wrap around.
I believe that the sun is a physical item. Hold on, I believe based on Melodone's work.
Bro, can I just? I'm almost done.
Go ahead. Go ahead.
I'm trying to get back to where I was. Just give me a second.
Okay.
You're still going off of the. I can't even get back to it, man.
Okay, but hold on. So you said I'm going off of the idea that the sun is a real item.
Oh yes, yes.
Go ahead,
dude. Bro, Mello's dome work is kinematics. The whole globe model was built on watching the sun. You're not going to find a contradiction in sunspots throughout the seasons based on that. That has nothing to do, looking at sunspots has nothing to do with the shape of the Earth.
Okay, so on the globe, which we're looking at now, I'm standing at a place on the globe, I'm looking west, and I'm seeing the sun set. I want you to tell me, where is the sun really? If it's not, so you're saying it could be anywhere else.
No, I'm not saying it could be anywhere else. I'm saying it's following a circuit around us at the equator where it has a 90-degree GP for people.
Okay, but hold on.
Hold on. Let me just finish the thought. And people, you just asked me to answer the question about where I think the sun's at, and in the middle of doing that, you interrupted me.
Go ahead.
So
you're talking about the sunset. You're saying that it is. I asked if it is where this sun is when it's setting.
Yes. So what we're looking at here, the true position is just following a circle around us. What we perceive is the arc and the antarc and all of that. That is that is latitude dependent for the observers. That's why I've been reiterating this. So when you go back to the God's eye view of it and you're like, well, if an observer is standing here and the sun's over here, how can they see two different suns? It's like you keep
you're telling me that that's reality. You're telling me that you keep saying a God's eye view, but there's no problem of taking a God's eye view of reality. who cares? It's just I'm getting above the Earth.
No one's ever seen it, and you're merging two conceptual models based off of apparent positions that don't truly change in physical elevation. That is the
No, I'm asking you, you
significance.
keep going back to that. I'm asking you, let's just go simply, not go difficult. Let's just say simply, can we get above the Earth and look down at it?
No.
Conceptually.
We can't, no. Not even conceptually,
What
what would be the purpose?
Because I'm asking you a question. Like we need to know the layout of the continents. Do you not agree that they are the AE map layout?
Yeah. I'm
Okay.
sure that it resembles something like that. But
Me
what
too.
we use to navigate it is two hemispheres of stars merged together.
Okay,
Based
but I'm not
off
talking
based
hemispheres
off
of-
of them saying that there's a physical elevation.
Here's what I'm worried
change.
about is when I was in Antarctica, I was looking south, knowingly looking south, and I saw the sun. Okay, that completely destroys what we just said about the flat Earth. It cannot be I'm looking down at the Earth and I see the sun south of me in Antarctica, because guess what? At that exact time, it's above the people's heads in Australia. So you need to explain to me if I'm either supposed to believe that what I saw to my south was some figment of my imagination, even though I felt the heat from it. The heat was coming from the sun. So therefore, it can't be some apparent position. It could be an apparent position that also generates heat, I guess. I'm not confused how that would even work. But the real sun is 30,000 miles behind me. So guess what? On the globe, I can pull up the globe like this, and that sun that I see, that's the only sun. Nobody else sees a different sun. That's the sun. I don't need a mystery sun. I don't need magic suns. I don't need refracted sun. That's the sun. And if it's above the people's heads in Australia, guess what I know? Australia's on the other side of that ball. That's what it must be.
You need a physical elevation change for the sun as well.
Okay, I'm glad you keep going back to that, because I already told you I will check into that. So you keep saying that. I'm hoping that it's as solid as you think it is, because if it's not, you have to be a globe earther.
I know, because you keep going back to the apparent position and reconflating it. Like we could just call it here.
There is no reconflating. There is the fact. It's a fact that in the south, people look south to see the sun, and it's the same sun that the people in the north see. Okay, so
I don't. The only thing I disagree with is that it's observer dependent, like individual to them. It's not the same one that you're looking at in the sense that you think it is, that you could like draw a triangle to a physical object.
Okay, but if you're looking at it and it has sunspots on it, then the other sun as well has sunspots in the same spots, right? So now the apparent sun carries the sunspots of the real sun. And how do we know which one's real and which one's not? We wouldn't know. Yeah. Okay. So that's what I'm saying. So really what I'm being left with is there's two different models for me to choose from. One of the models where I can say, see sun, there's sun. Okay, good. I get the sun. The other one is anything can go. I don't know what the sun's doing. I don't know if there's multiple suns and they all have the same sunspots, but I can't call them the same sun, or else the Earth's a globe. So, I mean, anybody who's at this point stays a flat earther is very, very, very open to the ideas of magic and mystery. And even though you have to then believe God is a deceiver, because God made the world that answers every question by saying sphere. That's it. Answers every observation we make from the ground, except for the one that you brought up. So I'll put that in there. If Alan's right that there's an observation, then I can no longer say that every observation that we make of the sky matches the globe, because according to Alan, it doesn't. But I haven't got to that point yet. I'll report back. But if it does, then every observation matches the globe perfectly. The globe describes everything. The flat Earth doesn't describe anything. In fact, it requires you to believe that the sun could be anywhere. We don't know where the real sun is, because, yeah, you might see it in the sky, Jeran, and it might be heating you up, and it might have a hot spot on the water, but it also might be above Australia's head 30,000 miles behind you. So you just have to, whatever. I guess it's just mystery. For me, I don't like that. That feels very weird. Whereas the globe, yeah, it feels weird because I don't feel like I'm on a globe. I don't feel like I'm spinning around. I don't feel like I'm on a ball. However, if it answers every question and every observation I make, guess what? I live on a ball, period. There's no way that it could answer every question. And actually the truth be that God just deceived us. He said, I'll put this sun here and make it look like it's a ball, but really it's a magic refraction, double-sided, double helix firmament dome that happens to just make magical qualities where the sun appears wherever it needs to be. And it just so happens that the sun happens to be where it would be in a globe. It's really weird. Really weird.
Can I comment real quick on the God deception thing? Okay, yep. So I don't think that's necessarily the case. When I looked into the history of Japanese cell nav and Chinese cell nav, what I found was They actually invented celestial navigation. They invented the celestial sphere. They went to the south, mapped the same thing. They had their own way to determine latitude based off of shadows produced by the sun throughout the day and year. And then they also came up with a ratio for when they would change in length to determine latitude. So they had a whole system for all of this. They had a whole system for categorizing stars as they transited over the Beijing meridian, and they actually changed their cosmology from being geocentric flat earthers with the kind of like conceptualizing it as a square. They actually changed it to being rounded because like the way that they see is still flat, but they changed the way that they talk about the heavens and stuff, because what they realized is that the heavens that they see, the celestial bodies that they see, aren't real. And it's like they were talking about it as an illusion, and like it's an apparent thing. It's not physical. So their whole cosmology was based on knowing that what you see in the sky doesn't represent physicality, and that you don't actually see that, and that there's a limit of vision. They actually derived everything that we're using right now for cell nav to the direct equivalent, because what happened in the 1600s is the Jesuits came by and basically stole their whole methodology and then reproposed it as it was derived from Greeks, with all this missing history where there's no firsthand information. Bro, there's firsthand documents from like all the Chinese stuff where they invented trigonometry and all this stuff.
You need to talk to Austin and remind him that him and I found this paper that was written by some Japanese guy in late 1800s at one of the world's fairs. And in all the documents we can find, it says that he had a working model of the flat earth, and that it was based on ancient Japanese or Chinese, whatever. And it was a working model that everybody could go see at this world's fair. And no matter what we looked at, we could not find any description of it. Oh, you did?
Yeah, I'll pull it up real quick. I'm screen sharing.
Okay. Are you talking about this same kind of people that are doing, you found it? Where did you find it? I know we couldn't find it.
So somebody linked it on Telegram, like the image of what it was. And I didn't know what it was specifically, but I was like, oh, I'm pretty sure I know what that was. So I started started the investigation, and I found it. Give me 1 second. I'll pull it up. And
right. It was the guy who displayed it at the World's Fair, right?
Yes, sir. Yes, sir. Give me 1
Yeah, because I would like to see that, because again, what the difference is, what you're describing when you said it's based on longitude, latitude. Well, longitude, latitude have the North and South Pole. So
yeah, dude,
I can't really picture a flat Earth person or a flat Earth group using longitude, latitude, because what it means is that 0 degrees is in infinite places. Sorry, 0 degrees, 90 degrees south. Sorry, not 0 would be the equator. And 90 degrees south would be an infinite amount of places, right? Because it's that entire circle. That's what's crazy about when like Duffy asked Flatzoid where the South Pole was. Because, oops, what am I doing here? Clicking on OBS instead of this. When he asked him where the South Pole is, because the crazy thing about this map is that the South Pole is everywhere out here. This is the South Pole. Even though it's one spot, it's all these spots.
Yeah, but that's a projection of the coordinate system. So like, that's not, it's fine, dude.
Right, but I get what you're saying, but you're not allowing us to understand what the real world is. So I understand that this is a projection. Okay, great. We can say that. But I think that the world has to have a real shape, meaning if we really got above it conceptually, wouldn't it look like this? And the answer is yes, if the Earth is flat.
I agree. It does look something like that, but we use a coordinate system derived from the stars from our position on the ground. But
right, but we use the distances. We use the distances based on that as well, meaning that if you find two places in this near the South Pole, their distance would be very close to each other. However, these two distances would be 40,000 miles away.
Well, the distances
in real life
are going to be internally consistent because a meter is a ratio of the terrestrial meridian itself. So any distances you
that's a globe proof.
What? It's a ratio of a coordinate system, bro. It's not a globe proof. So
it is, because the coordinate system is a globe.
The coordinate system is spherical. It has a
bisecting
meridian.
So you're saying that the distances are matched. Of course they match, but they don't match this.
When we both talk over each other at the same time, it's super productive. Let me tell you about this model real quick, and then I got a dip.
Okay, I got a dip too. Go ahead.
All right. So here we go. This is what was found here, and what we see is.
Oh, sorry. Bring this up.
Sorry, yeah. We see the equatorial plane, and we see the celestial here. You see these domes here. These domes represent how you see the heavens, and they're separated to represent 4 different continents. The way that they conceptualized it is that there was like a localized dome over the continents that projected the stars in the way that they see it. And what they have over here is a central axis that extends up. The way that this works is that...
Does that cause the eclipse?
What? Can you just...
I wonder if he's... I wonder if he says that it causes the eclipse. It'd be, could be that the sun goes behind there and then it flashes, the light wouldn't get across, it would block the moon. Go ahead anyway. I mean, it would show the shadow on the moon.
Bro, this is a fucking conceptual model to hold up things that are dangling that reflect light on the,
Yes, I know.
mirrors that are here. So that's just...
Okay, go ahead.
So there were strings attached to here, like little chains, and they had gemstones and different metals on them. And then you would shine light on them so that they would be reflective. And then inside of these little areas here, these were little glass domes that have latitude and longitude on them. And the celestial bodies, as they go in a circle above us, get displayed as different arcs. And then as this was set like as a planetary gear ratio, where once it completes 90 turns, it's basically changing in elevation as it's going up and down. So what you'll see is the positions of the celestial bodies change in the reflective dome here, creating a north and south pole. They had all of this all mapped out. So like when you translate what all the stuff means here, this is like they knew all about this, and they didn't change cosmologies to be globe lads. Like it wasn't until like the late 1800s, about 200 years after the Jesuit influence, did the Chinese change to being globe lads. They had a whole system of navigation, latitude and longitude. That's completely identical to what's used today.
Right, but I mean that wouldn't ever be able to match reality because again,
they were the first people to sail around the world. What do you mean?
Okay, I didn't say you can sail. It doesn't. You can have a model that you've brought up 2,000, 3,000 years ago that allows you to sail the Earth. It doesn't mean that it's the correct model of the Earth. So when you go back to that model, how could you have stars that are circumpolar, like we looked at earlier in the south, on this model? It's impossible, Alan.
It's not impossible, dude.
Oh, so show me how jewels are going to hang from those strings that are going to then circle the north-south pole when they're on the other side of that little stick.
Listen, whether or not it's possible to demonstrate or not, the Chinese did it, mapped it out. It works.
That doesn't mean we live there. I don't understand what you're saying.
It doesn't mean that we live there, that they merged it together and you can do it now.
You cannot make the stars do circumpolar around the South Pole star. You can never do that.
No, nobody needs that to happen, bro.
That's what happens in reality.
They literally invented the celestial sphere in the north and in the south, mapped it together. You think they weren't smart enough to go, oh, you know what? This probably means we live on a sphere. 200 years of Jesuit influence before they accepted it.
Right. So why didn't they we'll just go along with these guys that are telling us things that aren't true?
Using the same system. Yeah, basically.
Okay, well, that doesn't make any sense. People who came into a observatory and said, hey, this is the actual truth, they would go, no, it's not. This is the truth. We make better observations. Guess what? They came in there and they made better observations and better predictions. And then the Chinese said, it's a globe.
Name the better observations. There was a 13-second difference.
You.
No, you didn't. There was a 13-second deviation.
Is there circumpolar stars in the south?
They used these circumpolar stars to navigate in the south. They mapped them out and made a whole latitude longitude system based off of eclipses. Bro.
Right, but this model doesn't work on that. How are you going to make stars circumpolar in the south?
This isn't the model that they use. Number one,
oh,
you asked me about a thing that was in a world fair, and I told you what it was and told you how they said it works. That's all.
Right, I was hoping that it would explain things, but it doesn't explain things because that cannot work with what we observe in the south.
Well, bro, you haven't even seen the dangly stuff on it reflecting at different altitudes, so I don't know if it does work or not. But that's what they said. This is what it was based off of.
And that thing turns once a day, right?
No, it turns however you turn it. However many times, however fast you turn it, and then it's set on 90 turn intervals, so it raises and lowers in elevation per 90 days.
Right. So 1 day is one turn.
Sure.
So I'm just saying that the stars that are on the inside of that disk at the top would be the northern stars. The ones on the outside of the disk are going to be the outer stars, but they go all the way around the outside. Yet in the little dome down there, it only can go around the other side, and they have to stay within this Sigma Octantis, which just isn't possible. It's just not possible.
It's not possible. Yeah. All right.
Yeah, that's all. But I will look into what you said. I will make a video about it or get back with you and we can have another meeting because I agree with you that the globe Earth, the reason I'm a glober is because I've realized now that it predicts all that I see. So until it doesn't predict something that I see, then I can have a problem with it. So for now it does. As far as the sun and moon, that whether they're upside down or not, whether they're moving in which direction they're not, everything matches the globe. And then the other thing is, I've never found anybody who has been able to debunk Google Earth. So Google Earth places everybody that we know on a sphere and shows them what their observations would be. So one person out there better be able to say, Jeran, I live at this location. I'm looking at what Google Earth says the sky will do, and it's doing something different. And you won't find that. And so where does that mean that we live? You guys want me to believe that it's possible for them to place us all on a sphere and our observations match everywhere on the sphere, but we're not really on a sphere. And if that's true, then just show us another version of something that matches the same thing, but you'll never do that because it's impossible. How could you show something that matches the observations of another place, even though it's a different shape completely? It's just not going to happen. But go ahead, tell everybody where they can find you and how they can get more information and where they can do that themselves as far as the Cel-Theo or whatever you call it. What is it called? Oh, I have to read the rest.
The celestial theodolite. So yeah,
sorry, can you stay for 5 minutes if I rush through these super chats?
Yeah,
I just want to know if there's any questions for you. I'll get past the ones that aren't for you. So for the eclipse simulation, did Alan account for the fact that the personal dome would cause each observer to see the sun and moon at a different position in the sky?
Yes.
Okay, I would think so. Okay. Yes, the answer. Thank you very much, Pink P. Floyd.
It's based on the angle that the observer saw it at and then the distance of the triangle. So yes.
Okay. Mr. B6034 says, Alan, is it possible that you have a mistake in the calculations that you have made in your celestial theodolite?
It's highly unlikely. We're at 24 weeks of celestial theodolite updates. No one's refuting the math. It's always like trying to attack the methodology or the analysis.
Okay, we got Sick Doctor 1 says, how is it that now you can use the lights in the sky to determine the shape of the Earth?
Well, I was never bound by any sort of dogma, and the entire globe model is laid out based off of looking at things in the sky and the apparent positions. So the best way to refute that would be to find a way to show that the true positions don't change in elevation and it's always apparent. That would be a good start. So that's why we went with that. It's dogmatic as hell to say don't look up at the ground, because a measurement without an external reference is just circular. So like if you were to, like if you were to build like a force to line situation that's literally attached to the Earth that could exist on either model, doesn't prove either. It's like using a ruler to measure itself. It's retarded.
I agree. Okay, good. We've got from Jesse says, looks like a globe, but it's just an illusion. Yeah, yep. Okay. Science Minded says, see email for printable model for Alan, etc. Simple geometry of 6 airports. Wait, Science Minded says, see email for printable model for Alan, etc. Simple geometry of 6 airports. Okay. Jesse says, Alan lied again. The difference between flat and globe is 25 miles is 400 feet and easily distinguishable. His method fails in a lot of cases. Okay. We've got fake super chat for $420. Thank you very much. I do appreciate fake super chats. My favorite. Only 4 left. Galaxy Soup says, can Alan explain why never in recorded history have we seen the sun's angular size change over the course of an entire day from sunrise to sunset, confirmed simply with a solar filter? Well, it does change maybe a small, tiny bit, but not nearly what it needs to. Do you have an answer?
Yeah, my answer is that if we don't see the physical sun, what we see is an apparent object.
Okay. We've got Sean Hawkins 666. Alan, Antarctica isn't named that because of its Antarc. It's because there are no bears there. Arctis is Latin for the bear. Okay. Jesse says, by answering it's just apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be a globe. Well, I mean, he says, by answering it's just an apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be as a globe. So you would say that, yes,
that's my premise. The whole globe was constructed from watching the sun and the stars. We've done tons of presentations on it. Like that's our premise.
And Pink P. Floyd says, Alan, does the apparent sun provide apparent warmth or real warmth? It's a good question.
Ooh, great question. There is a huge asymmetry in the climate in the south versus the north in terms of being directly at the poles or whatever. So,
one's water and one's 10,000 feet high. It's a little kind of different temperatures there, water level or 10,000 feet high, different atmosphere. Okay, that is it, I think. Thank you very much, Super Chatters. Do appreciate that. All right, now you can say your final word and where they can find you and get more information on the
All right. If you want more information on the celestial theody, you can go to publish.obsidian.md/space audits and click on the celestial theodolite section, in particular the bounty section, if you want to learn how to participate. Like I said, we do have a prize pool so we can get some more terrestrial measurements. If you want more information about the eclipse, click on the eclipse tab. You can see the PDF that Brian made for us. He has all the math and everything laid out. And then in the comments, there was a couple of comments from some people on YouTube that had questions about the data and all that. The PDFs and responses to those questions are in the documentations here. If anyone has any meaningful, substantial refutations to the math or the process that we used for the eclipses or the celestial theodolite in general, just send me an email with your critiques. Doing it in PDF format would be preferable. That way we can go over, individual points and go point by point and stuff. If you want to join the discussion and talk to us about it or whatever, we have a Discord channel dedicated to it. It's called the Cel-Theo, but you can find that on our Discord. That's discord.gg/ethercosmology, and that's ether with an A. And if you want more YouTube stuff, my YouTube channel is at @space_audits. You can go there. We do celestial theodolite updates and discussion every Monday at 8 p.m. Eastern. So if you want to discuss the celestial theodolite, you can go to, we actually do that on Earth Awakenings. It's a more public server because we've banned a lot of people from ours, but we go to to a public server and have our update there. So anyone's free to ask questions and stuff, et cetera, and go over the data. Sadly, there's been a lack of participation on the globularist front, and everyone's relying on our boy Jesse over there to disseminate all the information about it.
Yeah, no, it'd be good if some people did look into it and at least, get to an answer there. Because again, if we can start to show some of those things to be false, that Alan even said, if you can show that change in elevation, then he sees no reason to remain flat. So it's something we should work on, and at least, or at least I need to know. Okay, I guess in my eye. At least I need to know why it is that the observation is not matching the globe, because I'm under the assumption right now that there isn't any observations that I've seen or heard of the sky that don't tell us that we live on a sphere. So if we don't see an elevation change from each person, then there's a problem.
Yeah. And not only did it not match, the globe, so-called, it actually contradicted the Kepler/Newtonian distance that they give, which I don't know if you're familiar with all that stuff, but it's basically how they derive the distances to all the planets and stuff. It's just a ratio of how long it takes to complete a circle.
And I've said that before, right? Yeah.
Yeah, over the time it takes to complete it. So the distances could be anything, but they're set on what was calculated from Kepler, and then they can also derive newtons from that. And because they're using big G and big M for that, they're asserting like, okay, it must be this distance, therefore, and that based off of this mass, there's this much gravitational potential between them to cause this velocity over this distance to complete that circle. So it actually contradicted that as well.
Okay, gotcha. Any final words? Anything else you want to say?
No, that's it, man. Thank you. I apologize for getting heated, and I probably probably gave some snarky looks and stuff at you, but
it's all right. I'm okay with it. I'm accepting it. All I care about is getting to the truth. I feel like I've already got there. So at this point, I have to be ready to, take people coming at me with apparent disproves or debunks of the globe. So let's see if they happen, if they stay up, or so Jesse can still ask questions and y'all answer.
No,
that's from Icy Spin.
No, you can't actually ask questions if you're on screen showing the equations, going over the math, been given several PDFs in the same time that you're saying that you haven't been given the math, and saying that it's a different math equation, even though a new equation hasn't been shown to be where it's different. Like, you can't just lie endlessly and I'm still going to talk to you. That's literally retarded. I'm not doing that. If your answer is just to lie and obfuscate, you can't participate. And that'll be determined. And that was determined over the course of like 15 episodes where we gave Jesse unlimited time to speak and answer all his PDFs. We even did the PDF exchange program with him because the stuff he would start critiquing was just ad nauseum ridiculous nonsense that had nothing to do with refuting the actual null hypothesis or showing how the elevation change is being physically demonstrated for the globe. So if you're not doing that, then you're doing something. Yeah, if you're not doing that, you're doing something else. And if you're doing something else, you can do your own presentations about the thing that's not what we're doing.
Okay, I just love liars in the chat. Is my favorite. So this person says here, Jeran bans anybody who disagrees with him, which I have not banned anybody. I don't ban anybody from YouTube. So if one of my mods did, then you'd probably have a problem with them, not me.
Dude, I'll say this. I often ban people I disagree with.
So he says, once again, add Jesse, once again, a liar. Plenty of Globers on Ether cause, just not liars like you. Jeran actually bans anyone who disagrees with his recently found retardation. No, I don't. So I don't know what you're talking about. It's a recently found retardation. It's so funny It's just funny to me. I'm supposed to believe this guy in my chat, Galatrix Bear. He's smarter than every single physics professor in every single college that there is. That's what I have to believe. So who do you think's more dumb there? Me or him? It's like, give me a break. This guy's smarter than every physics professor that's ever existed. Same reason why surgeons are not playing operation at the childcare. Nobody wants to give them the view. Oh, sorry, don't know what that is. Just seeing somebody said I don't look at the chat. So when I'm having a debate or talking to somebody, I try not to, or else I've seen it happen. I remember I was moderating debates and I would see people looking at the chat the whole time, and then they would just be terrible in the debate because they weren't paying attention. They were not even listening to the other person. They cared more about what the chat says, and they even change what they're going to say based on what the chat says. I don't want to do that. So I don't do that.
Same. And you're so right to do that. That's why I don't look at chat either when I'm doing stuff.
I've seen everybody, they become who their chat wants them to be. I can name 10 people that are exactly what their chat wants them to be.
Yeah.
Rocket launches are just skateboards paying ride to the dome. Oh, that's just a joke. All right. I was just thinking if there's anything else there. So is Alan and Shame at Jeran? What? Jeran, Alan banned me in less than 10 seconds when I said hello on the Ether Derpology server. I have it on video. That's from Max.
Yeah, like I said, I do ban indiscriminately and for completely random reasons. I have no idea who you are, no idea what you said. If you got banned for just saying hello, you probably said it at the wrong time.
Okay. I mean, it's scary to think about, though, that, I mean, you do realize that is a pretty vicious echo chamber, calling it ether cause or whatever that is, right? I mean, that's what an echo chamber is, right? If nobody really
you're going to start critiquing something that you don't really know anything about or why.
I'm asking you, it was a question.
Who the history of that guy is. I don't
know.
No,
I just asked you a question. I said, your ether cosmology is a pretty big echo chamber, isn't it? No, you can say, no, it's not. We all disagree all the time.
Sorry, I misheard you then. No, we have Glob lads on there that disagree and provide meaningful substance advice and stuff, like for the math and everything. Like it's a mixed group of people, man. What we don't tolerate is like just outright lying. Like that's absurd. And people that do that and waste time and argue endlessly with no conclusion over stupid shit. Like this isn't the place for that. Like, so.
I get it. I mean, if somebody has a direct reference, they should bring it like in a PDF form or say, they can come into my channel and present it. I don't care. In a condensed version, but you should be able to show why somebody's wrong about something or why their understanding of it is wrong. For instance, if he's wrong about the drop of the sun and moon or whatever, then we should be able to explain it easily why he's wrong. It shouldn't
we don't even know what that guy in particular is wrong about, though.
Yeah, I don't know.
So
says
like,
I banned,
and that's the thing. Like, doesn't matter, but if like people that are on other servers, right? Because it's a small community. We're all on the same different servers, right?
Okay.
And what people will do is they'll be on one server. You give them an explanation to something, then they'll be on another server and be like, I've never heard an explanation to this. Like, we don't do that shit here. And like, if you behave like that, you can't come and be a part of our community. If we want to interact with you, we go to whatever server you're on and do it that way. Like, we're actually doing research, looking for meaningful refutations. If something gets refuted, the argument gets dropped. It doesn't go anywhere. Like, we don't, like, if you come in and do nonsense and you're a nonsense person, you get shown the door real quick.
Okay. See if there's anything else here. Send your fluids to Foundry. Alan says he doesn't tolerate lying after spending 3 hours lying. Shame because you can't handle the math. All right. I think that's everybody. All right. Thanks, Alan. Appreciate it.
Sorry. Like real quick, like that's a perfect example. Just spent 3 hours lying. I just spent 3 hours showing, data of no elevation change, like the significant takeaway from this, but it's like, I'm somehow lying about that. That's literally.
Well, I'll find out about that. It's going to be one or the other. Either it was a lie or it's true and it needs to be explained. So one or the other.
Yeah.
So I appreciate you bringing that information up because I think it's good. And I think if Globers would have handled things a little differently, maybe this wouldn't have gone as far as it did, because I do think that, like, if I now just go make fun of Alan and call him a bunch of names, and then I'm not getting anywhere. That's not going to change his mind, and it's not going to change my mind. So instead, I'll take what Alan is saying, and I'll go and weigh it out and see what happens, and then try to bring it back to him and say, this is why you're wrong, or I have to explain why, if he's right. So that's the way it should go, rather than just laughing. I get why Globers do that. I get that for the most part, it seems like at this point, it's like a foregone conclusion. But I still think when somebody's got a legit reason, I mean, we have to believe Alan. We have to take him for what he's saying, that he said he would be a globe earther just like I would say before, like, oh, if you show me 24-hour sun footage from the south, I would be a globe earther. So Alan's made the same claim here that he would be a globe earther if we showed drop in those celestial bodies. So must be a reason why it doesn't show drop. So let's figure it out. That's all I'm saying. Sound good?
Well said, man. Appreciate it.
All right.
It was nice catching up with you.
You too. Take it easy. Later. Guys, what do we have coming this week? Anything else? I've got tomorrow. I'll be on with, I don't know if he's recording.
All right, lads, we're going to wrap up now. We'll be on the EtherCause Discord. If you're not banned from there, the Discord is discord.gg/ethercosmology.